we won't get to the negative exponents part till the end of the lesson. In the earlier part of the lesson, we're just cementing in the rules of exponents. So here we were supposed to find that there are 2 that are correct and 4 that are in error. It says expand each original expression to verify that it's correct. If it's not correct, then identify the mistake and simplify to the correct answer. So here, if you expand this, that would be, writing out all the factors. X times X times X times Y times Y times X times X times X times X. We notice that there are indeed 7 X's and 2 Y's. This one is correct. If we're using the rule, we're just adding the exponents on the X. The 3 and the 4 added together give us 7. And the Y, nothing changes. For this one, we have 2 times 2 times 2 times 2 times 2 times 2 times 2. What should that be? 2 to the 7th. It should be 2 to the 7th. So this one was incorrect. All right, for this one, if we expand it, 7 times 7 times 8 times 8 times 8 over 7 times 7 times 7 times 8 times 8. 7 divided by 7 is 1. 7 divided by 7 is 1. 8 divided by 8 is 1. Excuse me. 8 divided by 8 is 1 again. This is indeed 8/7, so this one is correct. Which means that the next 3 should all be incorrect. So for this one, it's 3 times 3 times 3 times 3 times 3, 5 3s, and then 2 more 3s, is what to the 7th power? Should be 3 to the 7th, not 9 to the 7th. He thought it was 3 to the what?
To the power of 10.
How? He multiplied the exponent.
Yeah, Paul, why did you think that? Bro,
That was you.
Yeah, it's 3 to the 7th. And if you ever forget the rules, just spend a little bit of time expanding 1 or 2 of them, and you'll go, oh, yeah, okay, that's the right rule. It doesn't take long. All right, so here, 6 squared over 6 to the 5th, so that's 6 times 6 over 5 6 multiplied together. Here we've got 1, here we've got 1. What do we have left in the numerator? What do we have left in the numerator? That's the top.
0.
Nope. We've got 1 left in the numerator. Because when we divide these, we get 1 over 6 to the 3rd. So that one was incorrect, and so was the previous one. Here, if we have z cubed divided by z cubed, that'd be z times z times z over z times z times z. And what are you left with? 1. Not 0. All right, if you haven't already, please quickly go through number 2. All right. Feel free to check with the people around you. Don't let your friend be wrong.
I got this. 16x times 5x.
16.
Yeah, because 4 to the 6th power is 16.
4 to the 6th power is not 16.
No, 4 to the 2nd, I meant.
Okay, I thought you said 4 to the 6th power. I was like, what?
What? It's wrong. I never knew that.
All right, let's see how you're doing on those. All right, the first one, let's see. Who's in desk 9? Oh, that would be Sophie. All right, so I'll take a volunteer for the first one then. Yes, Christian.
2 to the power of 7.
Yep, 2 to the 7th power. Thank you very much. For B, desk 10. What'd you get for this one?
2 to the power of 3.
Yep, this is 2 to the 3rd power. All right. For C, Cooper.
5 to the power of 3 and then x to the power of 6.
Yes,
Correct.
5 to the 3rd power. By the way, does anyone know what 5 to the 3rd is off the top of their head?
75.
125. You did 25 times 3 instead of 25 times 5.
Oh, 125.
Like a minute and a half ago now.
Yes, sir.
Yeah.
Einstein Albert.
And no one sits in desk 3, so I guess I have to do that one. So if you want to leave it as a power, it's 4 squared times 5 times x to the 4th power. And since it's talking about rewriting them with exponents, I would just leave it that way. If I ask you to simplify it, I would probably simplify this to 80x to the 4th. All right, let's move on to page 2. So this should be reminder stuff. I just want to kind of get all this well cemented in your head. So in the exponential expression, 3 to the 5th, 3 is called the base and 5 is called the exponent or the power. Same thing. For each of the following, simplify the expression given and then complete the explanation of the rule. I'm going to give you guys a couple of minutes to do that. Simplify it and then finish the rule. Make it a complete sentence. Try it on your own first and then And again, make sure that your friends around you aren't wrong when I call on them.
That's what I did.
Oh, yeah, exit, so it's anyone have an eraser? Sammy, do you have an eraser?
Do you not have one?
No. Oh, what a catch.
Good catch.
It's so we just subtract, x power 12 versus x to the power 7 would be an x to the power 12. Can we see how the once you practice the rules?
For C.
X to the power 7. For 8, you can see for C.
Add the exponents.
Yeah. Subtract the exponents. Yeah. Well, you gotta also add x to the base. Yeah.
It's already says with the same base.
With the same base, but you're gonna keep the base. You gotta always write it as a. You have to make sure. You gotta use.
I thought I already said C.
Did you write?
Keep the base and multiply the exponents.
Look, literally, it's in pen too. I can't read that. Your handwriting is so bad.
All right.
Worse than my ancient hieroglyphics.
So let's see how you did here. All right, desk 11.
You add the
Oh, whoa, 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 whoa. This part.
x to the 12.
Thank you. X to the 12th. And then desk 1. What's the sentence? What's the rest of it?
Combine exponents.
No.
Oh,
You tried that yesterday and I told you no then. Let's see if we can get. I thought one of your friends was supposed to be taking care of you. What happened, guys? You're falling down on the job.
I signed up for the daycare.
So, Paul, help him out. What should he have said? Yes, add.
Yeah, that's what I meant. My point, bro.
Yeah. You got to be careful about what you mean versus what you say. All right, let's see. Oh, desk 3, we're back to that again. This is going to be x to the 7th power. And then desk 12. How do you finish this sentence? When dividing two exponential expressions with the same base? Yeah. Keep the base and subtract the exponents. What you said was fine. All right. Sammy, what is this one? Yeah, x to the 12th. Thank you.
Sammy.
And then Barrett, how do you finish this?
Keep the base and multiply the exponents.
Thank you very much.
Good job, Barry.
Keep the base and multiply the exponents.
Yeah, I think Barry and you got like a 30. I think you did not.
Now, here's where we get into something a little new. What happens if the power in the denominator is higher than the power in the numerator? Wondered Paul. I knew you were wondering that. So, to help him figure it out, let's simplify the same expression two ways. Let's simplify 2 to the 4th over 2 to the 7th by expanding the expressions. So expanding, that means writing out all the factors in both the numerator and denominator. And then simplify using giant ones. So I just use, basic ones. What's left in the numerator?
3, 0, 1.
1 over, as a power, what's left in the denominator? 2 to the third power.
Third. I read it wrong.
All right, so now let's simplify using the rule stated in 3b. You're like, wait a minute, 3b. Keep the base and subtract the exponents. Well, what's 4 minus 7?
-2.
Try again. 4 minus 7?
You said -3.
It's -3.
That's what he said.
I thought you said -2.
Oh,
No, he said -3.
My fault. So, let me show you on a calculator that those really are the same thing. So if I do 1 divided by 2 raised to the third power, it's 0.125, and if I do 2 raised to the negative third power, it's also 0.125. Okay, so here's the thing, and this actually causes a lot of problem in future math classes. People think that a negative exponent makes your answer negative. It does not. The negative exponent basically says this belongs in the denominator instead of the numerator, or if it's actually already in the denominator, that it belongs in the numerator. Okay?
TI-84.
So, yes, they are. So let's simplify these two different ways. Let's write it as a fraction and it is an expression with a negative exponent. So as a fraction, this would be 1 over 6 squared, right?
Yes.
With a negative exponent, it would be
Negative.
6 to the negative 2 power.
Could you say 6 negative squared?
No.
Oh.
It's one of those vagaries of English. You just don't say it that way.
Oh, yeah.
All right. As a fraction, what would this be?
1 over m.
1 over m. As a negative exponent, that would be m to the what?
Negative first.
Yeah, negative first power, exactly.
Yes. It is 1.
All right, what would this one be as a fraction?
1 over 10 to the third. 1 over 10 to the third.
1 over 10 to the third, which is
10 to the negative 3.
10 to the negative 3. All right, shh.
Got the wind knocked out.
All right, let's look at these. Simplify each of the following expressions two ways. First, by using a rule of exponents, and second, by rewriting the expression with a negative exponent as a fraction, and then simplifying the resulting multiplication problem. All right, so using the rules, if we multiply two numbers together, what do we do? What's the rule? Keep the base and do what?
Add the exponents.
Add the exponents. Thank you very much.
Yes, like fine.
So this would be 6 squared. Now let's rewrite. We're going to rewrite the expression with the negative exponent as a fraction. So this is going to be 6 to the 5th times 1 over 6 to the 3rd, which would be 6 to the 5th over 6 to the 3rd, which is, 6 squared, or 6 to the 2nd power.
Yes.
It works out the same either way. So what would we do with these two? Well, if we're multiplying two expressions that are exponents together, we keep the base and do what with the exponents? Add them. That would be w cubed. If we rewrote it as a fraction, we would have w to the 5th times 1 over w squared. That's w to the 5th over w squared is w cubed.
Incredible.
have you ever wondered why they talk about squared and cubed for second and third power? So, how many dimensions does a square have?
Two.
2. And how many dimensions does a cube have?
3.
3. That's why it's called squared and cubed.
It makes sense now.
Again, it's one of those oddities, though, in English where you have these special words for some of them, but not for all of them. All right, so here we'll keep the base, and we'll add the two exponents together. So that would be 10 to the negative 2 power. If we rewrite it, it's 1 over 10 to the 4th times 10 squared, which would be 10 squared over 10 to the 4th, which is 1 over 10 squared. So it's the same thing. That could also be written as 10 to the negative 2. So when the exponent is negative, basically what you do is you're going to take the reciprocal. You're going to flip it over. Right, Ben?
That device, right? This instance. Why you on that device?
All right.
It's on board.
So,
Scoliosis.
last part, we have worrying Teresa. I understand what happens when an exponent is positive and what happens when an exponent is negative. What happens when the exponent is 0? So, x to the 5th over x to the 5th. Let's expand it. So that's 5 x's multiplied together. It's 1 times 1 times 1 times 1 times 1 is
1, 0.
1. 1, 0.
10. 10. He said 1, 0.
If we use the rule of exponents, what should we do with the two 5s? We should subtract them.
X over 0. I mean,
X to the 0.
Yeah, yeah.
So x to the 0 power is equal to 1. There is, since you guys are an advanced class,
Thank you.
provided that x isn't 0. 0 to the 0 power doesn't really mean anything. There's a few expressions in math that don't have any meaning. That's one of them. Another one is 0 over 0.
Isn't that just 0?
Well, the numerator would say that it's 0. The denominator would say it's undefined. Who wins? We'll get to that.
So it's undefined. Because you don't know who wins.
It actually depends on how we got to those zeros.
Everyone wins and they split the prize.
Everybody wins. Hey, hey. No? All right.